The GPT model. Let's see. The GPT model was introduced by OpenAI in 2018 in this paper, Improving Language Understanding by Generative Pre-training. The architecture of the GPT model comprises of basically the decoder part of the transformer, and it's repeated multiple times, as you can see 12 times here, and this constitutes the GPT model. So in order to train the GPT model, what do? So typically the way it's intended to be used is that we train the model, we pre-train the model to get a pre-trained model, and then there is the process of fine-tuning to be used for specific applications. And this thought process is similar to the way BERT came up with, the idea of pre-trained embeddings that can be used for different things. So what is the objective function in the pre-training part? So the pre-training is completely unsupervised. So what we are doing here is predicting the next word based on previous words. Pretty much that's what the objective function is based on, right? And that's why it's also often called an autoregressive model. And as we talked about, there are 12 layers of the decoder, and also the decoder actually uses masked self-attention that we saw in the transformer model, where basically we are only attending to the left context when we do the self-attention, right? Then there is supervised fine-tuning. So in this step, the idea is to adapt the model to different tasks at hand, which could be like classification or entailment, similarity, multiple choice, so on, whatever the task is, right? So, so for that, usually we add a layer at the end with the appropriate loss. So in this case, we added a layer with softmax activation if you want to do like a classification task, and the loss could be some form of cross entropy loss. Right, that's what we see here. And what they also say in the paper is, apart from the loss that we added for the task at hand, let's say we have classification, so we added the cross entropy loss, but it makes sense to add an additional term, which is the auxiliary objective. So in this case, they said that along with the cross entropy loss, during the fine-tuning process, they also added the language modeling objective, the loss from the language modeling objective that we talked about earlier, which is like predicting the next word. And what they say is, by taking a combination of these two losses, we actually accelerate the learning process and also get better results. So when the GPT model was evaluated, it was compared with its predecessors, which was the transformer model, bidirectional LSTMs, ELMO, and so on. Another interesting experiment from the paper is the follows. So an experiment that was done was to see transformer has like a number of decoder blocks, like 12 decoder blocks. Do we need so many decoder blocks? So if we transfer only n number of decoder blocks, what is the effect as opposed to transferring the weights of n+1 decoder blocks? So as we increase the number of decoder blocks that are transferred, we see that we are able to learn better, which shows that all these different layers in the transformer model are really essential to capture the semantic structure in the data and to be able to capture all the stuff that it's learning. How do we use GPT? So we can use GPT using the Hugging Face Transformers library. We can also do it in PyTorch, but here we are doing it in Keras. So you can actually get like a pre-trained GPT model, and you can get like whichever version of it you want. And once you do that, you can also give like for few short learning, you can give a few examples. For instance, here we are looking at the sentiment classification task, and I have 3 examples here along with 3 labels. Now what I'm going to do is I'm going to have an additional softmax layer here, which is suitable for sentiment classification. And I'm going to say the fine-tuned model is like, I'm adding that layer, I'm making it along with that layer basically. And then I can compile the model with the appropriate loss, which is cross entropy loss in this case. We're just using this one loss here. and then I'm actually going to train the model. When I train the model, I typically have an option to fix the previous weights, or I can train all the weights in the model. Here we are training all the weights in the model. And once we train this model again, we have the fine-tuned model that is trained, and it can be used to make predictions. So to summarize, we looked at the GPT model. We saw that it is basically the decoder part of the transformer model repeated many times. It is an autoregressive model that is very suitable for text generation tasks, and the original paper, the way it works through this model is to pre-train it on a large corpus and do a fine-tuning process for various tasks, and the paper shows that it can be used for various different tasks. Thank you.